The huge squid was written off as a myth for generations. The world finally realized the rumors were true in 2004 when scientists took the first pictures of a live, gigantic squid in its native environment. However, there is another extremely similar species on the opposite side of the globe. How is that even possible? In two entirely distinct oceans, how could nature produce the same creature? And how may evolution accomplish it a third time? Join us as we go deeply into the rationale behind one of the most amazing examples of evolution, the colossal revelation. The creature I'm talking about is the colossal squid, and despite what you might assume, it's not a close relative of the giant squid. They're not the same species, not the same genus, not even the same family. You have to go all the way up to their order, Oegopsidae, before you find any shared classification. That's like saying humans and lemurs are basically the same because we're both primates. And yet, look at them. Massive bodies, huge eyes, powerful tentacles, deep-sea hunters. If you showed someone photos without labels, they'd swear these were cousins. But the colossal squid lives exclusively in the freezing waters around Antarctica, diving deeper than giant squids ever venture. Meanwhile, giant squids roam temperate and subtropical oceans worldwide. These two apex predators of the deep have never met. They're evolutionary strangers who happen to become nearly identical solutions to the same problem: how to survive as a massive predator in the deep ocean. Ghosts of ancient squids. Both species trace back to a common ancestor, probably some primitive deep-sea squid that existed 60 to 100 million years ago, back when dinosaurs still walked the earth. But here's the problem. We can barely prove that ancient squids existed at all. Squids are terrible at becoming fossils. No bones, no shells, just soft, squishy tissue that decomposes in weeks. The only hard part of a squid is its beak, a razor-sharp structure made of chitin, the same material as insect exoskeletons. If a squid dies and gets buried quickly under sediment, that beak might survive millions of years. That's it. That's our entire window into ancient squid evolution. So we're left connecting dots across massive time gaps. At some point after the dinosaurs went extinct, that ancient squid lineage split. One branch became the Architeuthidea family, which eventually produced the giant squid. Another branch evolved into the Cranchiidae, the glass squids, and somewhere in that line, the colossal squid emerged. Here's the twist. They didn't inherit their size from a giant ancestor. Both evolved giantism independently, millions of years apart, in response to their environments. Evolution took two totally different squid families and said, you know what would work great here? A massive deep-sea killing machine. And it was right, twice. Why giant squids got giant? Giant squids got their size through deep-sea giantism, a well-documented phenomenon where creatures living in extreme ocean depths tend to grow larger. The deep sea is cold, dark, and under crushing pressure. Food is scarce, predators are rare but deadly. In that environment, being big solves multiple problems at once. A larger body conserves energy more efficiently. It stores oxygen for longer hunting dives. It regulates temperature better in near-freezing water. And most importantly, size itself becomes a defense. When you're 40 feet long and weigh 500 pounds, very few things want to mess with you. Giant squids are built for speed. Their bodies are sleek and hydrodynamic, designed to rocket through the water using jet propulsion. They inhale massive amounts of water into their mantle cavity, then force it out through a siphon in explosive bursts, reaching speeds estimated at 25 miles per hour. That's faster than an Olympic swimmer times 4. Their tentacles can stretch an additional 20 feet beyond their body, lined with suction cups rimmed with tiny serrated teeth. When they hunt, they likely ambush prey from below, using those giant eyes to spot silhouettes against the faint light filtering down from the surface. One explosive burst forward, tentacles shoot out, and whatever fish or smaller squid they grab gets dragged toward their beak. The beak is what really makes them apex predators. It's harder than a bone,
shaped like a parrot's beak but the size of your fist and capable of slicing through muscle and bone with terrifying efficiency. Behind it sits the radula, a tongue covered in backward-pointing teeth that grinds flesh into pulp before the squid swallows. Giant squids are elegant death machines, perfectly adapted for their environment, but they're not the only ones who figured out this design. The Antarctic tank. Colossal squids live in the Southern Ocean, the frigid waters surrounding Antarctica. It's one of the harshest environments on Earth. Water temperatures are just above freezing. The pressure at the depths where colossals hunt would crush a human instantly. And unlike the relatively well-lit waters where giant squids roam, colossals spend most of their time in the abyssal zone, thousands of meters deeper, in total and permanent darkness. In that environment, speed isn't as valuable as endurance. The colossal squid evolved under the influence of both deep-sea gigantism and polar gigantism, the tendency for cold water species to grow larger to conserve heat. The result? A creature that can weigh up to 1,650 pounds, making it the heaviest invertebrate on Earth by a massive margin. Colossals are built like tanks. They're shorter than giant squids in total length, but far more muscular, with a thick, robust body that stores energy and retains heat. They probably don't chase prey at 25 miles per hour. Instead, they're ambush predators, drifting through the darkness, waiting for something to come close. And when something does, the colossal squid doesn't rely on suction alone. Its tentacles are armed with rotating hooks, sharp and curved, designed to impale prey and lock it in place. Imagine getting grabbed by something with meat hooks for fingers. That's what it's like to be a fish in the wrong neighborhood. Could it happen again? So, what would it take for a third truly giant squid to evolve? You'd need the right environment, deep water, cold temperatures, high pressure, and a stable food source. You'd need a squid population isolated long enough to evolve independently, probably millions of years. And you'd need selective pressure that favors size over other traits. The thing is, we're already seeing it. Several large squid species seem to be halfway there. The Dana octopus squid can reach 350 pounds and lives at intermediate depths worldwide. The robust clubhook squid grows up to 13 feet long. Neither is truly giant yet, but they're showing signs of the same evolutionary pressures. Give them a few million years in the right conditions, and who knows, we might end up with a third massive squid species. Maybe we'll call it the Titanic squid or the ridiculous squid. I'm open to suggestions. But here's the sobering part. Convergent evolution creates similar weaknesses. Giant and colossal squids both share the same primary predator. They both rely on stable deep-sea ecosystems, and they both face the same existential threat: humans. Climate change is warming the oceans, industrial fishing is reducing prey populations, deep-sea mining threatens habitats we've barely explored. These creatures survived for millions of years, but they're not adapted for the changes humans are causing in mere decades. We only photographed a living giant squid 20 years ago. We've never seen a colossal squid in the wild. We're still discovering how they live, hunt, and reproduce, and we're doing it while their world is changing faster than evolution can keep up. The giant squid and the colossal squid are masterpieces of evolution, proof that life finds a way even in the most extreme environments. Let's make sure they're still around for future generations to study, fear, and marvel at. Because honestly, a world without Kraken would be a lot less interesting.